Okay, so this is another video in our Introduction to Physics video series. In this video, we'll be looking at vector quantities. I am your host, Junior Roberts, coming to you with realjuniorroberts.com. So let's begin. Okay, so the objectives of this lesson. So at the end of this lesson, you are expected to be able to define the term vector quantities, right? To be able to give examples of vector quantities and to be able to represent vector quantities mathematically and graphically. Okay, so the first thing that we'll ask ourselves is what are vector quantities? So a vector quantity is any physical quantity that can be expressed completely as a magnitude or size and an associated direction. So what we're saying is that if we have a physical quantity, right, for it to be a vector, it has to have a magnitude, in other words a size, and an associated direction for us to actually consider it a vector. And some examples of vectors include force, velocity, and displacement. So force is considered to be a vector because there's a magnitude. Let's say we actually push on an object. We're pushing on that object with a magnitude, a force that has magnitude, and we're pushing in a particular direction, east, west, north, or south. So that is why we say that a vector quantity, for us to get a full understanding of what that vector quantity is, we need to know its magnitude and also its direction. Okay, so how do we represent a vector mathematically? So we can represent vectors mathematically using letter symbols with a forward pointing arrow to indicate that the quantity is a vector quantity. For example, we can write the force vector F as F with a forward pointing arrow, right? And this forward pointing arrow tells us that we're dealing with a vector. So whenever we represent a physical quantity and we also have a forward pointing arrow above it, the quantity in question, or the quantity that we're looking at, is actually a vector quantity. Okay, so let's look at some examples of vector quantities. So we look at the vector quantity, its symbol, and its associated unit. So the first one we look at is velocity, right? The physical quantity is velocity and it's a vector, and we see we represent it as a common V, and again we place our arrow above the symbol to indicate that it's actually a vector. And the unit of velocity from before, as we know from before, is meters per second. Next one we look at is displacement. Its symbol is S, and again we have our forward pointing arrow, but its unit is M, which stands for meters. Next one is acceleration. Again A with our arrow above the symbol, and its unit is meters per second squared. Next one we look at is force, right? Again we have our forward pointing arrow, its unit is Newton. And finally momentum, a capital P, and again we have our forward pointing arrow and its unit is kilogram meters per second. Okay, so how do we add vector quantities? Now, since vector quantities are represented as a magnitude with an associated direction, in order for us to successfully add vectors, we will need to take into consideration these two properties. So we need to take into consideration the magnitude of the vector and the direction of the vector. So when we're adding vectors, we use what is called vector addition. Right, so we use vector addition, and in vector addition we actually take into consideration the magnitude of the vector as well as its direction. So in other words, we take into consideration on what exactly the vector is doing. So we have to know its magnitude and also its direction when we're actually doing vector addition. So let's consider a classical example. Let's say we look at a game of tug of war, right, in which two teams are applying a force in opposite direction. Since the forces applied by the two teams are vectors, we can consider vector addition if we wish to add these two force vectors. So here I have a diagram, right? So this team is pulling this way, and this team is pulling in that direction. So that is the direction of the two vector forces. So let's say this team is pulling with a force of 5 Newton, and this team is pulling with a force of 10 newtons. For example, for us to actually add these vectors, we will need to take into consideration the magnitude. This is the magnitude of the vector, and also the direction. So because this team is pulling this way, let's say this is east, and this team is pulling west. For us to actually add them, we need to take these two directions into consideration, and as it is right now, these two forces will actually subtract, right? So we'll get a vector that is 5 Newton. So 10 minus 5 will result in 5 Newton. So when we find the vector sum of multiple vectors using vector addition, the resultant we obtain is also a vector having a magnitude and a direction, and we call that new vector our resultant, right? The resultant is defined as a single vector having the same effect as all the vectors combined. So in our previous example, when we actually add the two opposing vectors by subtracting them, the vector we obtain will be a new vector called the resultant, and that vector will have the same effect as those two vectors acting in opposite direction. So how do we represent vectors graphically? Now, since vectors are quantities that are expressed as a magnitude and a direction, we can conveniently use arrows to represent a vector graphically. So here we have an arrow, right, representing some vector. Let's call it v, right, and the length of the arrow drawn indicates the magnitude of the vector, and the direction of the arrow gives us the direction of the vector. So this length here, the length of the arrow drawn, right, gives us the magnitude, right, and the direction in which the arrowhead points gives us the direction of the vector. Alright, so some properties of vector quantities. So the first property we look at is the magnitude. So we know that a vector quantity has a magnitude. In terms of its direction, it has an associated direction, and we use vector arithmetic to add vectors. So let's quickly recap what we have learned so far. So we've learned that a vector quantity is any physical quantity that is completely represented as a magnitude with an associated direction. And when writing vectors, we use letter symbols with a forward pointing arrow above the vector to indicate that the quantity is a vector quantity. And some examples of vector quantities include force, momentum, and velocity. We can represent vectors using arrows in which the length of the arrow indicates the magnitude of the vector, and the direction of the arrow indicates the direction of the vector. So again, this was Junior Roberts coming to you with realjuniorroberts.com. If this video was helpful, please like, consider sharing so others can benefit, post your questions or comments below, subscribe, and hit the bell so you are notified whenever I post new videos like this. Thank you for watching.